We're going to have our first panel for today, and the guest will be discussing privacy-enhancing technologies. So we will have Hitesh from Mirana to be the moderator, please.
Thank you so much. Hello, hello. Everybody, Hyunok, Guy, Chiro, Danny, please. All right, we have a full house. While most of the audience is busy eating, we are going to discuss the secret life of PETs, right? But before we do that, let's go and give a brief introduction of who we are, what we are building. I will start first. I am Hitesh. I lead research at a venture fund called Mirana. Previously, I was a dev at Consensus, and I've been in the industry for more than 10 years. I'm very excited to talk to these gentlemen about an area they are deeply passionate about. So why don't we start with you and tell us what you are doing and tell us about what you are building.
Hi, nice to meet you. I'm Hyunok Oh from the General Proof Research Center, so I'm the chairman. And also I'm the CEO of the ZK company, which is developing some private preserving application using the General Proof. And also I'm the professor at the Hanyang University. So actually I'm researching about the General Proof. So like almost 10 years. So yeah, so now I'm developing some General Proof, proving system itself, and also developing some privacy preserving applications using General Proof.
Hey, I'm Guy Itzhaki. I know it says Guy Ziskind. That's the other guy at Fhenix. We make it easy. We use the same name across the board. I'm the CEO of Fhenix. A little bit about my background. I spent many years doing trusted execution environment work. I used to work at Intel for many years. Did also led Intel's fully morphic encryption business development team. And last year, basically figured out that it's really the right time for FHE to come into the blockchain space. For those of you who don't know what FHE stands for, fully homomorphic encryption, it's a very novel encryption technology that enables you to run computation on data while it's encrypted. We're building Fhenix. We're an L2 on top of Ethereum. We'll share more about it in a minute. And I have to congratulate you on the name of the panel. I love it. Like, I think it's really perfect.
Thank you.
Yeah.
I'm Chiro, founder of Orochi Network. We are an R&D lab in Vietnam. We do research in crypto, and we're interested in zero knowledge proof, FHE, and also other stuff like MPC. We build a product is provide the provable data, and I really love the concept that we build the verifiable data pipeline that can prove every step of data processing to provide the data that people can verify with cryptography proof.
Hi, yeah. Hi everyone, so I'm Danny Willems. I'm a cryptography engineer / researcher at O1 Labs. Mostly have a background in mathematics, moved into cryptography like around 7-8 years ago. Working more on snark verifiable computation in general. And so at O1 Labs, what we do, we incubated the Mina protocol, which is more the first, I think, L1 ZK that have been in production for like some years now. And so when we build the infrastructure, we also build like toolings for developers to write ZK application. So we started O1JS that people use to build application, and we're also working on ZK VM in particular that we call O1VM, and we're doing research in general. At the moment, it's mostly folding schemes and ZK VM related research. So yeah.
Thank you very much. This is a very illustrious group. Although we already started talking about ZK, FHE, secure multi-party computation, I think we have to set the stage about what are PETs. PETs are privacy-enhancing technologies, of course, but what constitutes PETs? Of course, ZK, SMPC, FHE. There are other techniques as well, like TEEs, trusted execution environments, differential privacy, etc. So the first question that I would pose to the group and would love to get your thoughts on is that what do you think out of all these privacy enhancing technologies is going to create the most impact for privacy in Web 2 and Web 3? What are your favorites? So I would start with Guy. And,
sure.
Yeah.
It's a really good question, and I'll answer it with, I think, a couple of variants. For me, and I don't know how many people here are familiar with the differences between like FHEs and TEs, so I'll just take 2 minutes just to explain. Maybe with TEs, trusted execution environment, enables us to run computation in a trusted hardware. But when we're actually running the computation itself, the data within the trusted hardware is in the clear. Then we have ZK. This is a ZK Accelerate Day, so ZK proving, and I think everybody here understands what ZK, and it's a proving mechanism. And full-homomorphic encryption is another computation technology that you can compute over encrypted data. Now, the question was, out of all of them, and we can also include MPC, which one would make the most impact? And actually, I would say it's probably a mix of all of them. And the reason that we've been hearing about all of them many, many years, but we can't really say that they've reached like critical mass, is that I think each of them provides key benefits on one aspect, but lacks on another. And the combination of all of them really brings us to the point where we can actually now finally addresses what the ecosystem really needs. And I'll give an example of, for example, like FHE is great. You can do computation on encrypted data, but there is no way to prove that the data that you're actually computing on is the data that you want to put on top of the chain. So you have to have ZK for that. And you also need to have MPC to decrypt, to maintain a share of a key that would be used to decrypt the data. So it's more about the mix of all of them that really enables us to provide what the market actually needs.
I think like pretty clear that you explained that we need to combine a lot of stuff. For example, like FHE, it can you can do computation on encrypted data, but you cannot verify the process. You can tell if the people just give you some random value or not. So, but when you combine with other stuff, it's going to create a lot of overhead to actually like generate the proof for FHE and other stuff. So I don't think like we're going to achieve the privacy sometimes soon in the future, but then we keep it in mind and build towards to the future where everybody can have the privacy.
Yeah. Oh. So yeah, same opinion. It's just very not nothing novel, but it's just a mix. It's different technologies fitting different needs, and nothing more than just said.
As you know that the general proof is kind of extension of the digital signature schemes, and like FHE and multi-party computation case actually is for the confidentiality. So it's trying to hiding the data itself. So I think which kind of tool we are using is depending on what kind of application we are developing. Actually, is it, for instance, if we are making sure that the data is processed correctly, in that case, we have to use the digital signature schemes like GKP, but confidentiality is more important. In that case, we have to use some like multi-party computation or the FHE. And also, the performance is very important. Then maybe the fast encryption scheme like multi-party computation or can be the possibility about that.
That's very interesting. So the consensus that seems to be emerging is that a lot of these technologies have to combine to enable privacy on-chain as well as off-chain. And the core, there are drawbacks and strengths of each technologies that are complemented by other technologies. For example, FHE working with SMPC or ZK and TEs maybe working together, right? But we've been chasing privacy for quite long, and these technologies have been around for quite some time. So what will it take to take privacy mainstream, both in like Web 2, but mainly in Web 3? And what are the main barriers? Are they technological? Are they regulatory? And for a layman who does not really care about privacy or does not have the right motivation to go after privacy, how do we enable privacy by default?
Yeah, I love this question because it always comes up. Like, okay, we've been trying to figure that one out for many, many years. So I think we alluded to the answer in the previous question, which is that for me, up until now, the technology wasn't mature yet, and it requires a mix of a couple of technologies to really provide the solution that is needed. But it's more than that. Even now, when we feel, okay, we sorted out the technology, we can figure out FHE with MPC and ZK, and we can actually meet what the market is. Now, it's really the question, okay, but what is the killer use case? And I want people to actually start thinking about it less in terms of privacy and more in terms of flexibility. Because once you start introducing the ability to do encrypted data on-chain, you actually unlock use cases and applications that you couldn't do before. And this starts from voting and auctions that are probably working today but not optimal, but progressing into DeFi and even at some point into confidential AI. And I think that's what we're currently working on, is bringing these one or two killer use cases that cannot just happen without on-chain confidentiality. And we can give a couple of examples in a minute. So I would say we should probably think about it as more of a hockey stick, where we're still at the phase of just building the infrastructure and building the awareness, very much similar to like real-world asset, where real-world asset were existent for, I think, since 2017 and only now starting to explode. This is going to happen to confidentiality and privacy-based technology just because it logically is something that's missing today.
Yeah, I think like for when the question comes to the regulation stuff, I think like no one of us can solve it. It depends on the government and all the stuff. But then when it comes to technology, I think like the biggest problem right now is we need to generalize a standard for what actually like privacy, how you shape it, and how you can convince people to use this. If there is no standard, like everybody will have different standard for their own system. And there one more thing I think it's going to change the view of privacy is the client-side proving. For example, like right now, you cannot guarantee that the server is done correct. You can do it on client side, and it will be something like very going to appear in the short term.
Before we move to the next participant, I want to quickly double click on the point around regulation, and I want to probably go deeper and get your views around how regulation actually is impeding privacy, or what we can do about regulation in terms of making it easier for regulators to regulate as well as for users to use. I mean, it's very easy to just say that, oh, regulators are coming out of after privacy protocols and we can't do much. But I think that's a very surface answer. So I would love to hear thoughts around what can we do about regulation, and what are some of the jurisdictions which are more progressive towards privacy?
Let me answer about that. Actually, before the regulation, I think, so actually I have some experience about developing some private preserving applications like voting systems and digital asset transfer, logistics. So in my experience, the most difficult part is not actually the regulation. It's more like a technology. Actually, designing of the secure protocol for each application is really hard work because it requires a lot of cryptographic expert level knowledge and also effort. And also it's not easy to prove the soundness and security of that application. Actually, those things, this thing is actually a hurdle of that, hurdle to develop the private preserving application. I think the regulation itself is actually helping to adopt the privacy in our application, actually. Yeah, I think.
Yeah, I would agree with that. I think we have this misconception that regulators prefer everything to be in the clear, and it's really not the case. Just think of Europe and GDPR, and the ability to protect users' IP is something which is important. And I would say pets actually solve that conflict between the ability to, on one hand, enable the regulator to get access to data while maintaining users' privacy. And the reason is that with pets, we can actually make sure that the regulator can see the data in certain conditions while making sure that nobody else can actually see that data. I 100% agree with you. We shouldn't look at regulator as somebody who's coming to chase like privacy preserving, even though that's like we're seeing that happening. The regulators themselves are still trying to figure out how to deal with crypto in general. But for really trying to pull in institutional projects into Web3, which I don't know how many of you have seen, like we did an announcement about the partnership with JP Morgan Chase about building their Onyx platform and introducing confidentiality to that, because they literally come and claim, look guys, for us to build a blockchain infrastructure, we need confidentiality. So that helps to pull in the institutional and brings this maturity that we're actually currently missing from Web3 today.
Yeah.
What do you think then?
Yeah, to add something on this, even the EU is already starting on integrating privacy. Let's see how they implement it, of course, but they are already integrating, like they are working on a digital wallet for identity, which I hope is going to go well. I think we should not go, I hope, really. So I think it's not against, but I think we should not be against regulator. We should not fight with them. I think it's just that we are here to provide the first research, the building blocks, proving that it can work. And after that, they build on top of what we're doing. But so there are already some projects which I hope is going to be in production, let's say soon. Hope, but so yeah.
Awesome.
Yeah, I just have one add-on to that. Like long time before, like when people create hash function and also digital signature, they also think like how we can use this in regulation. But then right now you see like everything like already here, and people regulator already accept the digital signature as a part of their infrastructure. So I hope that in the future, like or even in our lifetime, we can see that the regulator going to accept the cryptography proof and another kind of cryptography proof like ZKP and other stuff. It will be cool, and it also help to create the autonomous goal. Yeah.
Amazing. I think on the topic of regulator accepting a cryptographic proof, I think a lot of that kind of ZK proofs are generated on client side, right? Users' laptops, users' phones, and things like that. And so far, the lot of research that we have seen on ZK side is proving very large computations on L2s and then proving and verifying them accidentally on an L1, right? So that's not the privacy use case. That's a scaling use case. That's they are called validity proofs. What are the use cases of client-side ZK proofs? We have been looking at ZK TLS, where you can share data with a third party from a website in a regular TLS session while keeping more while selectively disclosing your data. So what are some of the use cases that can be built on top of things like ZK TLS or in general on top of client-side ZK proofs? And have we looked at what is the state of the art for client-side ZK proof generation? Yeah, I will start with you.
Yep. As I mentioned, we developed some private preserving application which are running on the like mobile devices. So when we are starting the project, what we are thinking is that the most important project will be the voting. So we start the vote. So voting case, the current station to generate the proof on the mobile device, it takes like 2 to the 10 seconds to generate the proof. Actually, it is acceptable to use the normal case. So that is, I think, most important application area. But the other important application areas will be the financial solution, like a Gcash and like a Tornado Cash. When we are sending some privacy money, in that case, that should be run on the mobile devices. So I think that proof generation time is almost same to the voting case actually. And some another application like a trading system, also very similar things. So those cases, I think they can be run on the mobile device, but I'm not sure about the other applications. Actually, depending on that performance improvement on the mobile devices.
What are you seeing on your side, Danny, from Owen Labs? And have you seen teams building client-side proof generation related products on Mina?
So as I said, O1 Labs first about the adoption. Just also to go back on this, we realized also that we had to build some layers. So Mina is it's been in the space for like 8 years now, 7, 8, 2017, 7. And we realized that we had to build first an infrastructure for people, so for the developers. And so after that, we had to build toolings on top of it to make client-side proof. So it's been, in the DNA of the project since the beginning. So O1GS is there to build this client-side proof. And about the performances. First, the developers need tools, and so O1GS is there to build more like specialized circuits. But after that, you want to build maybe more generic applications where ZK VMs, is there, and still, you've got the infrastructure to build there. So step by step, we're gonna go also on mobile application. I just think that we're also always talking about GPU, that we've got to improve also on GPU. I think it's not gonna be there the big market at the beginning. We're first gonna go on small applications for users, like developers are just gonna build simple applications,
That makes sense. What do you think, Karan?
I think I love the concept of client-side proving. The first thing, when you work as an engineer, it's running on client side and it run on your own device, and it's very cheap to perform compared to the other stuff. But then when you come to some real application, I think there will more interesting if people do something like 2PC. Like sometimes you need to do the computation, like you and also the issuer of your ID need to join a computation process to generate the proof for your ID. So it's going to enhance the privacy for you, but then also not going to harm the regulation stuff and prevent people to do the bad thing.
That makes sense. Moving from ZK to another moon math, which is FHE, and Guy, this question goes to you. How has FHE changed from Craig Gentry's original paper? I know things like TFHE, bootstrapping has been improving the performance of FHE. What kind of use cases are being built today? Of course, you are building Phenix. What are other interesting things that you are seeing in the wild? What you are looking forward to build in Phenix going forward?
I actually had the pleasure of meeting Craig Gentry 3 weeks ago. For those of you who don't know, Craig Gentry was the one who would say initially the first research around fully homomorphic encryption, I think over 10 years ago, and then he left the space and actually decided that, with everything that's been ongoing, he came back, and now he's back into FHE. But FHE, when people heard about it at the early days, it always been associated as very complex and very slow. There's been a lot of progression in that space, both in terms of complexity. Now to build on top of FHE, you don't need to be a developer, like a cryptographer. It's solidity-based. You just decide what type of data you want to encrypt and decrypt. So it's very easy to build confidentiality with FHE. And then also the performance part, there's been significant progression, both in terms of the FHE libraries, the schemes themselves. You mentioned bootstrapping, which is programmable bootstrapping, is part of TFHE, which it's one type of FHE. There are other FHE schemes that are maybe better fit for machine learning type of applications. So there's a lot going on in that space, and it's really progressing very, very well. What really gets me excited about FHE is, I can give a complete list of use cases. And we've talked about voting and auctions and DeFi, and all of it makes a lot of sense. But just trying to understand the ability today for users to pull in data from their Web 2 space, if we want to build a reputation model or a credit scoring model in the Web 3 space that would enable users to get better lending rate. How do you do that? So how do you pull that data? You need the ZK component to actually prove that you have that data in the Web 2 space. So you have companies like ZK Pass that provide that. But then now you have data on-chain, and now you can actually start computing over that encrypted data on-chain to start generating insights that can really mature this industry. And then lastly, and this may still be more of like a 6 to 12 months kind of space, it's everything around confidential AI or verifiable AI, which we're starting to hear quite a lot more. And that is the ability to do training on private data, and second, private queries, the ability to do queries on decentralized AI models in a way that's still encrypted. And this is actually progressing way faster than what we're thinking today.
That's super amazing. I think FHE in its fully blown state will change the way internet is run. And I'm not an expert on FHE, so I'm not sure how far it is. It's 2 years, 3 years, or 10. But I think that's going to be a seismic shift. I think we are closing on time, but I would be amiss if I do not bring up TEEs. I am not sure if any of you are actively looking or working on TEEs, but they have been the talk of the town. Everybody is building products on TEEs. People are doing order flow auctions on TEEs. There are block building on TEEs. There are multi-prover systems where people are using ZK on one side and then using TEEs on the other side for L2s. So they are everywhere. And this has come after where everybody was talking about how bad TEEs were, and they had multiple side channel attacks. You have to trust the manufacturer. Somehow the narrative has been flipped. So I would love to get the thoughts of the panelists here around what has changed and what are some of the use cases that TEEs are great for, and what, if you are building with TEEs, why, and if you're not building with TEEs or you're susceptible or you find them a fad, then why?
So I worked on TEs since 2017 in my early days at Intel. I think you're right that the narrative has changed. The problems hasn't changed. They're still susceptible to side channel attacks. When there is an attack, the content inside is hackable. Now, what changed is that the fact that there has been a lot of progression in use cases and applications that can use TEs, but even if the problem happens, there is a quick way to mitigate that problem. But still, I find it hard to believe that when we start getting into like significant amounts of assets and data, that you would feel comfortable running them inside a trusted execution environment. I think the industry would still prefer a cryptography-based solution versus a hardware-based solution. But the fact that these are fast and they're there is a good signal for us. It means that there is a need for the use cases. It's really up to us to bring the cryptography that will then oversuppress TEs once it reaches the maturity that we're now aiming to build.
I think, like, for me, I think that the concept of TE is very beautiful. If you can build some machine that can encrypt everything and you can do computation and the other people from the outside can touch into the secret and other stuff, it's cool. But then the implementation is horrible. And actually, like, only big corporation hands on those stuff. And for the rest of community and other people, they have no power to join that process to develop the TE. So I just hope that maybe like we have some community driven, like people do with the RIGFI, and we create an organization focused on develop the open TE or something. It will be cool. Besides that, like right now, like TE can be used by the hacker they abuse the TE to run the virus in the TE, and it will be the horrible future if you say that you bring TE to everyone.
Yeah, definitely. I think people are putting TEs on satellites, and they are doing infrared imaging of TEs to find out whether they have been changed. So I would, before we end, and this is the last salvo, do we have any contrarian view on TEs in this panel today? Like somebody who thinks that we should not touch it, we should stay on the cryptographic ramp, and TEs are not the way to go.
Let me say some short sentence. Actually, TE is giving the high performance compared with the cryptography approaches, but the problem is that actually the security, right? So we have to rely on the manufacturers, and also, so that means if the secure level is not going to be so high application, in that case we can be use the TE approach. But if we are dealing with some like a large amount of money or like a life critical application, in that case we cannot trust on the hardware approach because it can be hacked or it can be changed. So in that case we have to always use the cryptography approach. Yeah.
Awesome. I think with that, we can wrap this up. Thank you, gentlemen, for taking the time. And this has been the secret life of PETs, and we hope for a future where we have privacy by default. Thank you.
Thank you. Amazing. Thanks for sharing your valuable insights.